In this video, I am going to illustrate analysis of variance in the most simple way possible. We are going to assume that the data come from independent random samples from normal distributions. Can't be much easier than that, right? Let's say we have 4 groups. Nothing sacrosanct about 4. It could be 5, it could be 10, but 4 is pretty much the easiest way to go for fully illustrating the one-way analysis of variance. Let's say our 4 groups consist of an experimental treatment from the first experiment, an experimental treatment from the second experiment, a control from the first experiment, and a control from the second experiment. So we have 4 groups, normally distributed, super simple. But we do have another assumption for analysis of variance. We have to assume the population variances of the groups are equal. Of course, not the sample variances, that would be moronic, but the assumption of equal population variances actually is terminology in standard statistics. This terminology is called the assumption of homoscedasticity. Great word, homoscedasticity. Homo meaning the same. In analysis of variance, this is super important because we are testing hypotheses about population means, but by using different measures of variance. That's why it's called analysis of variance. And so, if this homoscedasticity assumption is violated, well, you got trouble. A whole lot of trouble. And that would take you into the realm of non-parametric statistics. But we're not going there today, at least not in this video. Now, there is another assumption. It's that we have independent random samples from all of our groups. And if you're a biostats students, these groups would be called study arms in the context of RCTs. But if you're taking a stats for psychology class, this video is absolutely perfect for you too. At this point, I hope you can see that this setup is exactly like that for the equal variance t-test, only instead of having 2 groups, today we will have 4 groups. But of course, with analysis of variance, we can have as many groups as we want. 3 groups, 4 groups, 5 groups, even 2 groups, as many as you want. And if you understand the equal variance t-test, like if you understand pooling the variance, well, this one-way ANOVA, this will be super simple, like a hot knife cutting through butter. And if you need a little review of the equal variance t-test, just see my video on pooling the variance for the equal variance t-test, and also my video on the equal variance t-test itself. So to recap, 4 independent random samples, the normality assumption, the homoscedasticity assumption, and the sample sizes of each group don't have to be equal. They don't. But if they are equal, it's called a balanced analysis of variance. But I am purposely not making the sample sizes equal so that I can show you exactly how to do this thing regardless of whether the analysis of variance is balanced or unbalanced. Obviously, we are doing an unbalanced analysis of variance. But if it was balanced, we would use the same exact mathematical methodology. The ANOVA hypotheses. The null hypothesis. The null hypothesis for analysis of variance is that the population means from each group or study arm are equal to each other. Not the sample means, that would be moronic, but the population means are all equal to each other. But it's just like in the equal variance t-test, only we have more than 2 groups. The alternative hypothesis. The alternative hypothesis for analysis of variance is that at least one population mean is different from the others. They could all be different. 1 could be different. 2 could be different. It doesn't matter. And this is called an omnibus alternative hypothesis. We have some formulas that may look complicated, but I am going to do my best to explain exactly what this symbolism means. We're going to eventually calculate the mean squared error between the groups. How many groups do we have? In analysis of variance, typically we have 3 or more groups. You can actually do it with 2 groups, and that's mathematically equivalent to the equal variance 2 independent sample t-test. But in practice, practitioners use the analysis of variance for 3 or more groups. So if we have 4 groups, we are going to be multiplying by 1 divided by 4 minus 1, which is 3, or a third. Now, multiplying by a third is the same as dividing by 3. So this over here is the divisor. But what does this capital Greek letter sigma mean? This tells us to add up in what are called iterations over and over again, the same exact, and this element after the Greek letter sigma, this is called the summand, right? So this is actually like computer code. This is an example of something called a loop. You start at the first group. I stands for iteration. Iteration number 1. You start at the first group. N sub I, N is the sample size of the first group. Y sub I is the group mean, the mean the sample mean of the first group. And then you subtract this thing called a grand mean, which is nothing more than the mean of all the observations in all the groups. You take this difference, you square it, you multiply by the first sample size. Then you go to I equals 2. That's called the second iteration. That means you take the sample size from the second group, you multiply it by a quantity, that's the difference between the sample mean of the second group, because we're on iteration number 2, and we're going to subtract that same grand mean, the mean of all the observations from all the groups. We're going to square it, we're going to do our multiplication. Then we go to the third iteration. We do the same exact thing. Sample size from the third group, sample mean from the third group, subtract the grand mean, the mean of all the observations in all the groups, all together, square it, do the multiplication. And if there's a fourth group, we do it again. Iteration number 4. And if there's a fifth group, we do it again. Iteration number 5. And we do this loop until we get to the last group, which we are going to call uppercase letter G. And that's how we get this measure of variability, which is called the mean squared between. And this measure measures how much variability there is between the groups. That's the big deal. Now, this mean squared within, this is analogous to the equal variance t-test's pooled variance estimator. See, if you remember the equal variance t-test, what we did was we took each sample variance, but we only had 2 groups, and we multiplied by the degrees of freedom to recover the original sums of squares, and then we divided by the degrees of freedom. Now, I can explain why this is. See, let's start with the first iteration. The first iteration says we take the sample size of the first group and we subtract 1. We then add it to the sample size of the second group, minus 1. We then add it to the sample size of the third group, minus 1. So we're going to end up subtracting 1 G times. This is the divisor. These are the sums of squares that we recover by taking the sample variance and multiplying it by the degrees of freedom. And it turns out this is a chi-square, this is a chi-square. Independent chi-squares divided by their degrees of freedom. When you take these under the null hypothesis, this divided by this becomes an F random variable. And so that's what we are going to be doing in a nutshell. Starting with the familiar. Let's begin the one-way layout using analogous methodology from the equal variance t-test. We will begin by pooling the variance just like we did in the equal variance t-test. Can't be simpler than that, right? I'm going to use Microsoft Excel to display the information because it represents tabular data really well. but I'm not going to use any of the statistical functions on Microsoft Excel. So you can follow along with your calculator and pencil and paper. You do not need Microsoft Excel to do this, but you'll see how nicely it organizes all the information. And of course, I will go slowly enough so that if you wanted to follow along with Microsoft Excel on your computer while watching this video on your cell phone, well, you can do that also. So pencil and paper, Microsoft Excel, whatever you want. Let's get busy. In order to do an analysis of variance, it helps if we add a few things to the table of summary statistics. Let's get a capital N. Capital N is the total number of observations in our entire study. And what I want to do is I want to bring it over here nice and close. And I want to add up all of these. What you have to do to start a calculation is actually hit the button that any ordinary normal person would do at the end of a calculation, equals button. And we're going to add all these things up. To add things up, that means take the sum. And we go parenthesis because it is a function. A function returns a single value, or it could be a vector. And now what we are going to do is we're going to click but not release. We are going to drag, and then we are going to release. Then we close the parenthesis. Now, any normal human being would hit the equals button because you're used to using a calculator, but you hit the enter button, and that adds it all up. I want this lined up, so I'm going to center it so it's lined up. Now, this wasn't in the original table, so I want to make this red just to remind myself that it wasn't in the original table. I made this myself, but, it's important, The next thing I want to do is I want to make a table for all the degrees of freedom for the individual groups, which is n-1, right? So what we're going to do, again, in Bill Gates land, you start with the button that any normal human being would end with, and that's the equals button. And we want to take this and subtract 1. And then, of course, we end with the button that's not the equals button because it's secret knowledge. 10 minus 1 is 9. Now, here's something that, you have to know. Someone has to show you this, but if you take your mouse pointer and you move it to this lower right-hand corner, it becomes called a fill tab. And shout out to Professor Mike Jones for teaching me this 20 years ago. Click, but don't release. Drag, and then release. Now, you can do this on the calculator. 10 minus 1 is 9. 5 minus 1 is 4. 11 minus 1 is 10. 10 minus 1 is 9. But it's nice to have it here because we're going to use it for something. The next thing we are going to do, now that we have the degrees of freedom from each group, n-1, what we're going to do is we're going to recover the original sums of squares. So I'll write SS for sums of squares. And let's do the first one. It's going to be n-1 times s squared, which would be 9, that's n-1, times this squared. So In Bill Gates land, you start with the equals button, even though any normal human being would end with the equals button. All right, so equals n minus 1, and then the times button is the asterisk, and then the sample standard deviation, and then the caret button, which is above the 6, 2 squares it. And then you don't hit the equals button because everything has to be secret knowledge in Microsoft land. So let me just show that I'm not lying to you. Hey Siri, what's 38.17 squared times 9?
It's 13,112.5401.
So I just want you to see I'm not lying. Now this Microsoft Excel is rounding this off to the nearest hundredth, but it's storing it way more than the nearest hundredth. So you don't have to worry about that whole round off error thing. Now here's the beauty of the Microsoft Excel. If I take my mouse pointer and I put it to the lower right hand corner of this, and I click, but I don't release. And then I drag, and then I release. I have just replicated that calculation. And if you're using a calculator at home, I want you to make sure that you get these numbers. And I'm going to put this in red just so I know for myself that I really have derived this, and this wasn't in the original table. Now, the next thing I want to do is I want to get the degrees of freedom within. And all that is the sum. Oh, and I have to hit the equals button because I'm in Microsoft land, is the sum of click, but don't release, drag, then release, close parenthesis, and then because you're in Microsoft land, you don't hit the equals button because any normal human being would want to. You hit enter instead, and this is the degrees of freedom within. And to prove it to you, to prove that I'm not lying, hey Siri, what's 9 plus 4 plus 10 plus 9?
The answer is 32.
All right, so you see I'm not lying. It does that. So that's the degrees of freedom within. So now that we have the sum of squares and we have the degrees of freedom within, we can get the mean squared within. I'm going to call this MSW for mean squared within. And what is this equal? This is equal to the total number of sum of squares. Oh, and I didn't add them up yet, so I have to actually do this. So let's get the total. And what I'm going to do is I'm going to go parenthesis TOTAL, just so that I know what I'm doing, if I were to look at this again. So now let's go equals sum, parenthesis. I'm just going to add all these up, right? And you can do that on your calculator. Close parenthesis. Again, do you hit the equals button like a normal human being? No. You hit the enter button, and this is your total. So maybe what I'm going to do is maybe I'll make this a different color just so it stands out. Let's make it this color. And I'm going to boldface it just so it stands out a little bit. And I'm going to make this the same color. Actually, maybe I'll put it, maybe I'll do it over here just so it's connected. So I'm going to call this MSW. And I'll write the equals so you see what it is. And I'm going to click this little justify thing to put it over here just so it looks good, right? And let's make a little space for this. And we're going to take this total And this is the total within. Just so that you know. And check this out. You can wrap the text. It's actually pretty cool. I mean, there are some good features in Excel, right? So what is this? This is the total. And really, these are sums of squares. So maybe I should write that just so you see it, So this is the total sum of squares within. And if I want to make it look a little better, I can do this just to make it look a little better. And what does this equal? This is this divided by this. That's it. So I'm going to hit the equals button because in Microsoft land, you start at the end. Yeah. And you're going to take this, the sum of squares within, and you're going to divide this by the total degrees of freedom. And then you're going to hit the enter button. And I'm going to make this blue, same color, and I'm going to make this bold. And you know what? Let's make it a larger font just so it sticks out. I want it to stick out. And maybe I'll underline it. Just because, and maybe I should italicize it just so you know how important this is. So this is actually the denominator of the F statistic. And technically, if you want this to be right, the F is lowercase. And technically, it's italicized. I mean, it doesn't matter really, but I mean, And I think I'm going to make this nice blue color. And I'm going to make this nice and big. And I'm going to make it bold just so you can really see this carefully. So this is the denominator of the F statistic. The reason why I did the denominator before the numerator is only because this is familiar. If you know the equal variance t-test, this is a piece of cake, right? You're just recovering the sums of squares, and then you're dividing by the total number of degrees of freedom. I mean, that's the equal variance t-test, not rocket science. But the next thing we're going to do is we're going to go doing the mean squared between. So I'm going to call this MSB for mean squared between. And what we're going to have to do first is we're going to have to get this thing called a grand mean. And I'm just going to call this GM for the grand mean. And let me wrap this, right? And this grand mean is what we get if we take all these 36 observations and we add them all together and we divide by 36. So we have 10 observations whose sample mean was this, 5 observations whose sample mean was this, 11 observations whose sample mean was this, and 10 observations whose sample mean was this. So we're going to recover the original sum, and then we're going to divide by 36. So we're going to go 10 times this, plus 5 times this, plus 11 times this, plus 10 times this. And we're going to take that sum and we're going to divide by 36. But I'm going to show you an easier way to go through this so that if you're doing this with pencil and paper and you just want to be like hyper organized so you get this right on the test, you can do this. So the next thing we're going to do is we're going to get the group totals. And I think I want to put the group totals over here. So let me get rid of this and I'm going to put this over here, and I'm going to put the group totals over here. And I'm going to wrap this just, So how do I get the group totals? So the way I get the group totals is I take this times this, just like I showed you in the very beginning. So again, Bill Gates land, you hit the button you'd normally hit at the end in the beginning. And you're going to go sample size times, which is the asterisk button, and then the sample mean. And that gives you the totals in each group. Hit the enter button instead of the equals button like any normal human being. Click on the cell, get the fill tab, click but don't release, drag and drop. So at home on your calculator, I just want you to make sure that you can get these group totals by taking this times this, this times this, this times this, this times this. So you can pause the video here if you want to. And I'm going to make this red just so it's clear that in fact, I'm going to make this a whole different color. I'm going to make this maybe this nice orange. Nah, maybe green. Green is a nice color. I'm going to make it green. Yeah. That's what I'll do. I'll make it green and make it look nice. So that's the group total. And now I want to get the grand mean, right? So maybe I'll put this here. And I want this to be the same color. So this is the color. I like this color. It's nice. So the grand mean is going to be this, plus this, plus this, plus this, because these are the totals from all the groups together divided by this, the total number of observations in the entire study, 10 plus 5 plus 11 plus 10. All right? So watch what I do. I hit the equals button because in Microsoft land, you do the thing at the end first. And then you go sum, and then the parenthesis button. And now I'm going to take all the totals. So I click on this. Now I released it by accident, but I think if I click again and hold it, I can still bring it down. Yeah, it worked. And now I release it. And I close the parenthesis, but we have to divide it by 36. So I hit the / button. Now, how do you know this is a / and not a backslash? Because if this is a person leaning this way, he, she, they fall forward. / this is the divided by. And then you divide by this, and then you hit the enter button, even though any normal human being would hit the equals button. And that's the grand mean. And what I might do is I may copy this over in this whole row. I'm sorry, this whole column. I'm going to just copy this over. I might need it. So I'm going to copy it over. And I just want to make sure I have this whole column having this grand mean. You'll see why. And then I'm going to take the fill tab, click, but don't release, drag, release. And I get the same exact grand mean. So this is the same, but you're going to see why I did that. And I wanted this nice color. And I think I might want to boldface this also, so it stands out. Okay, that looks good. So we got the grand mean, and here we have the individual group means. Now, what I'm going to do just temporarily, it's not that I really want to change this table, but I want it to be the same color. You're going to see why. So I'm changing the color, and I'm going to make this bold. Now you see the group means have this nice green color and it's bold, and these are the grand means. So by comparing the group means to the grand means, by subtracting and then squaring, we get the sum of squares. And since we have 10 of them in this group, 5 of them in this group, 11 of them in this group, 10 of them in this group, we're going to have all these sums of squares. So to make it easier for you to see, what I'm going to do is I'm going to make a nice little column for sum of squares between. And that's what we're going to do. And then we're going to add them up, and we're going to divide by 4 minus 1, which is 3. So that's where I'm going. And what I want to do is I want to make it this nice green color. And that is what we are doing now. All right, so the next thing we're going to do is we're going to get the sums of squares between from each group. So here's the grand mean, right, which is the same thing. It's the mean of all the subjects' scores, right? And this is the sample mean from group 1, group 2, group 3, group 4. So we're going to take this as the weighting, and we're going to multiply this by this minus this quantity squared. And we're going to do it for all the groups. So let's do it. Equals button, because in Bill Gates land, you start at the end, right? And then you're going to go the sample size in the first group multiplied by parenthesis. Here's the group mean. Then you hit the minus button. Then you take the grand mean. Then you close the parenthesis button. And now to get that squared, you hit the caret button. Oh, I didn't hit you hit the caret button for exponentiation, and then you hit the 2 to square it. And of course, any normal human being would want to hit the equals button, but you don't do that. You hit the enter button. What does this give you? This gives you the sum of squares, all 10 of them, for the first group. Now ask yourself, if you were using, now of course, you're going to hit the pause button and do this whole thing on the calculator if you're doing this with pencil and paper. But let's say you're following along and you want to do this on Microsoft Excel. You're going to hit the pause button, but ask yourself, what do you think you are going to do next? Time to think. Well, if you said you're going to click on this cell, get on the lower right to get the fill tab, click but don't release, drag, release, you would be right. So these are the sums of squares where you're taking the sample mean within each group, subtracting the grand mean, squaring it, doing it for all the number of observations in each group. And now we can add all these up. So I'm going to make let me make it this nice green color so you see how nicely it aligns. And I'm going to boldface it, right? And this is really important. What we're going to do now is we're going to take the sum of squares between, and we're going to divide this by the number of groups minus 1. 4 minus 1 is 3, so I can just do this pretty easy. So let's over here, let's call this MSB for mean squared between. And let me Well, actually, let me put it over here. And you know what? Let me put in equals so you see that it's equal to. And let me make it this nice green color so it matches. And let me boldface it so it matches. Okay, so what we're going to do is we're going to add all these up and divide by 4 minus 1, which is 3. Right? We have 4 groups. So when we get the sample variance from 4 groups, we're going to divide by 4 minus 1, which is 3. Okay, let's do this. So we're going to take the sum. Oh, I didn't hit the equals button. I forgot I was in Bill Gates' crazy land. So equals sum, parenthesis, and now we're going to click. And now we are going to click again and drag and then release. So that adds up all the sum of squares, close parenthesis, and then we are going to divide by 3. 4 minus 1 is 3. And then we're going to hit not equals like any normal human being, but enter. And that's the mean squared between. We have a mean squared within, that's the denominator, and we have the mean squared between, that is the numerator. So what I think I want to do is I just want to write numerator of the F statistic. And so this fits. Let me do this. I want this to fit. Yeah, that looks halfway decent. And let me do this. Let me make it this nice green color again. And let me boldface it. So here we have the numerator of the F statistic. And here we have the denominator of the F statistic. So now, what do you think we're going to do? We're going to divide, right? All right, so let's do it. So I'll do it over here. So I'm going to write F equals, and I'm going to move it over here just so it looks good. And then I'm going to take this and I'm going to divide it by this. So we're going to go equals button, because you're in Microsoft land, mean squared between, / for divide, mean squared within, enter. And we get 15.86185. And with data like this, you only have like 3 significant figures over here. I'm going to round this. There's too much precision here. So I'm just going to format these cells as a number. And I'm just going to round this to 3 decimal places. That's fine, but you learned how to round. And I'm going to italicize this because it's an F statistic. And I'm going to justify this to the left. And what I think I'm going to do is I'm going to put a border around this. Well, I don't need to do that, actually. That's overkill. So this is the F statistic. Now we need to find out whether it's statistically significant or not, but this is the F statistic. So we have an F score of almost 16. 15.862. Now we're going to need to look this up in the table, but it's probably a good idea when you do this to always specify the numerator degrees of freedom and the denominator degrees of freedom. So here the degrees of freedom within, that is the denominator. I'll put that in first. That's 32. That comes from here. And the degrees of freedom in the numerator, that's the number of groups minus 1. So since there are 4 groups, we have 4 minus 1, which is 3. So this is an F statistic with 3 degrees of freedom in the numerator and 32 degrees of freedom in the denominator. So let's look at this, and we'll open up an F table. And here we have 3 degrees of freedom in the numerator. And as you go down to 32, it's right here. It looks like it is 2 points. Let me make this a little bigger because it's hard for me to see. So we have to go all the way down to 32, which is here. And this is the numerator. So we go all the way down to 32 and we get 2 point, it looks like 901. So the critical value right here is 2.901. Let me put that in. 2.901. And this is the critical value. And this is at the 5% significance level. All right. Actually, you know what? I'm going to do it below it. I'm going to write alpha equals 5%. And I'll put it in parentheses so it looks good. Now I'm going to boldface this. And I will bring this over here. And I will bring this over here. And let me put an equals sign just so that it looks good, right? So the observed value of the F score is almost 16. This is a very large F score. What makes it very large? Well, the critical value isn't even 3. It's like 2.9. And so we have an F score that's greater than or equal to the critical value. So that tells us, I'll write it over here. This tells us the results suggest that the group means. Now, of course, these are population means. It would be moronic to say sample means, but I'm going to put it in anyway, just in case. So the result, now never say prove. If you were to say prove in my class, I'd take off like as many points as I possibly could, because you can't prove the alternative hypothesis because type 1 errors exist, even though this is really strong evidence. Still, you have to be technically correct, you know? So the results suggest that the group means are not all equal. And this is at the 5% significance level. At the 5% SIGNIFICANCE level. And let me do this, and let me wrap the text. In fact, let me and I didn't put a period at the end. But, well, Microsoft is sometimes so difficult. It's like, it makes things difficult on purpose, in my opinion. You have to know You see, I struggled to put a period at the end of the sentence in Microsoft Excel. So this is our conclusion, right? That's what it is. Let me write the word conclusion above it. That's what this is. It's a conclusion. Well, the underlining is so light. I could fix that, but it's not worth it. So the conclusion Microsoft Excel is sometimes very difficult. The conclusion is that the results suggest that the group population means are not all equal at the 5% significance level. So remember, with analysis of variance, the null hypothesis is that the group population means are all equal. And the alternative hypothesis is that the group population means are not all equal. At least one group mean is different than the others. So let me recap this whole thing that we did. We got an F score with numerator degrees of freedom of 3. 4 minus 1 is 3. Denominator degrees of freedom, we added up 9 plus 4 plus 10 plus 9. And when we added all those up, we got 32 degrees of freedom. That's where the 32 came from. We did the whole thing, and we got the F score that was almost 16. Very large F score. Very strong evidence against the null hypothesis. But even very strong evidence against the null hypothesis does not disprove the null hypothesis, because type 1 errors still exist in statistical inference. And with that, our episode comes to a close. This is Dr. J. Lee Noose for Biostats, summed up.